Hello, my name is Marcus Baker, student number 2016-04543. This is the submission for YouTube video accompanied by my progress report for ECE 5000 Electrical Engineering Design at Memorial University. My project is number 22, which is to design an Arduino and openHAB based 3-light on-off control system through a web page. Before we get to the testing, I'll quickly walk you through my detailed description of my project that you see in front of you. On the right side of your screen, you have the theoretical 3 different lights set up in 3 different rooms, which is our kitchen, bedroom, and bathroom. In the middle of your screen, you see a dark green box, which is different from my last submission. I created the housing unit for this project using a Tupperware container that I had laying around my house that turned out to be the perfect size due to the material restrictions that I could not go out and get something readily available to me because of COVID-19. I had to improvise a little, but it turned out working better than I expected. So I'm going to go ahead and take the top off just so you can get a better idea of what is inside. I know you won't be able to see it perfectly because it's a top-down view, but the progress report has several pictures from different angles that highlight what is inside much better, but I'll quickly walk you through it. On the very bottom, we have our Arduino Uno with a Ethernet shield connected on the top. On the left side of our container, there's a fairly large hole which a Ethernet cable comes out of that is attached to our Ethernet shield and runs into our router that you can see at the very top of your screen right here. So the reason my project is set up on the ground of my living room is because the router is the only Ethernet access point I have available in my household. So my roommates have been having to put up with my project sitting on the living room floor for the last couple of months, but they don't seem to mind. The other cable coming out of that large hole is the blue Arduino Uno power supply cable, which I have attached to an iPhone charging block. And when plugged in, this seems to provide a perfect amount of power to the Arduino Uno and gets the job done perfectly. So moving up the housing unit, we have a smaller Tupperware lid that I've placed there that my relay board sits on top of. This is because I want to separate the relay board and the Arduino Uno components so that they don't connect and risk the potential of short circuiting, because that would be quite dangerous and a safety hazard. So I know the plastic lid is not ideal and will most likely be updated for the final implementation of the project, but for now it seems to do the job. On the front side of the housing unit, we have 6 wires coming out of 6 different small holes. I have 8 holes drilled, and because of this is because my relay board came with 4 relays, and I'm only utilizing 3 for 3 lights. But if the user wanted to add another light to the system, this would be very easy. All he would have to do is write a simple a little bit of extra code onto our Arduino, our already existing Arduino code, and add a new item into openHAB and run the wires, and we would have a 4th working light. The only other thing that is in the housing unit is at the very bottom a white and red container, which is actually an empty pill bottle, a Tylenol bottle. And the reason that this is there is highlighted in my progress report, but I will quickly say that the cables, the blue power Arduino cable and the Ethernet cable, were very stiff, and the Arduino Uno was starting to move around in the base of my housing unit, and the cables could potentially chafe on the rough, rigid plastic from where I cut. So to prevent this, I just put an empty pill bottle in the bottom to stop the Arduino from moving in that direction. and I know it's not ideal, but it gets the job done for now and most likely will be updated for the future. For my power supply, which is right here, that powers the lights, is just an old 2-prong cable that I had laying around. I just spliced that off and it revealed a black, which was a hot cable, and a white, which was our neutral cable. So at the bottom of the screen, you can see a red Marette, 2 actually. And so I tied 3 hot wires into a Marette with the hot from our power supply, and 3 neutral wires, which are the white, into the white neutral from the power supply. The 3 neutral wires ran right directly to the lights, and the 3 hot ran into our relays. Our relays are connected in, normally closed composition. And I'd also like to note that the relay board that I'm using is a Lego 4-channel 5-volt single pole single throw relay board, which I purchased off Amazon. And so the wires run from the power supply to the relay, and then from the relay to the light. That is the hot wires. I'd also like to note that for the power supply wires, I used 14 2-gauge wire. The last thing to note before we get into the testing is the lights that you see, the light bulbs rather, were provided, the whole light system was provided by the engineering department and came with incandescent bulbs. And when testing, they got extremely hot very quickly. And I know this is a downside to incandescent bulbs, but for safety, I had some LED bulbs laying around, so I just switched those out, and we haven't had that problem since. So now we're going to get into the testing aspect. I'm just going to run into my room, because that is where I have my Microsoft computer, which runs my MQTT server, as well as my openHAB website. And this is where I will be conducting all the switches for my lights in my living room from. The switches are on the website, and you will see me changing them, as well as my MQTT server, logging all the pings and messages that it receives from openHAB, and then all the pings that it has received it on the Arduino. So I'm just going to go ahead and start our screen recording there right now. So in the bottom left of your screen, you should see what is my computer screen, which I will minimize my screen recording, and we have a command prompt on the left and openHAB on the right. So I'm just going to go ahead and I'm going to start up my MQTT server just by entering this simple command. So here we can see that my server is up and running. Over here on openHAB, if we quickly go to my settings and into my things, we can see that our system and our broker are offline. And if we just give that a second, since our server is up and running, it'll try and pick up openHAB. So in a second, we will see our server or our broker log that transaction that it is turned on. And there we go. Took a little longer than expected, but it did come online. So once this has started, it does not need to be stopped by the user and will only shut down if there is a loss of connection or power. So now that we have that up and running, we can actually go ahead and back out of this because we know our server is up and running. If we go over here to this tab, we have our house lighting control, which is our website. And here we can see the kitchen light, the bedroom light, and the bathroom light. So before we can go around and play with those, we actually have to turn on our relay board and our Arduino. It is important to note that our relay board, when there are no inputs, so a theoretical 0, the switches on it are actually closed. So it's important to plug in our Arduino first and then our lights, because if we plugged in our lights first, the Arduino or the lights would actually all come on, and that is not the desired result we don't want to start with. So I've just turned on our Arduino, and we can see our relay board LEDs are turned on there now because we are powering our relay board off of the 5-volt power supply from our Arduino Uno. So I'm going to go and plug in our lights now, and we can see that from the computer screen all lights are off, and with power supplied all of our lights are off. So I'm going to go back into my bedroom, and we are going to quickly go through the testing process. When we have 3 lights with only 2 options, from logic we know that there are only 8 possible cases that these lights can simulate. So in my progress report, which I'm going to pull up here, we can see this table with some cells that are highlighted, and these are the 8 possible cases that the lights in my system can implement. There are no more or no less, so no matter what the user throws at them, it will be one of these 8 cases. So for testing purposes, I'm quickly going to run through this table. I will not be able to see my lights because I'm in my bedroom and the lights are in my living room, but I trust that it will work as I'm confident in my product and I have tested it before. I will change each case and then hold for about 5 seconds to ensure that no delay has occurred and you can see that the product is working correctly. So obviously case 1 is all the lights turned off, which we have over here on the right side of our screen, and on out in the living room, all lights are off. So moving on to case number 2 is the kitchen and bedroom lights are off and the bathroom light is on. So right now the rightmost light in the living room should be on. We'll hold that for 5 seconds and then we will move on to case 3, which is the bedroom light on and the bathroom light off. So only the middle light out in the living room should be on right now. We'll hold. And then we will move on to case number 4, where the bedroom and bathroom lights are on and kitchen light are off. So we can see that that is working correctly. Moving on to case number 5, the kitchen light is on, bedroom light is off, and so is the bathroom light. So we only have the kitchen light, which is the leftmost light, on right now. Moving on to case number 6, we will turn the kitchen and the bathroom light on. And then 7, the kitchen light and the bedroom light. And then finally, the final case where all of the lights are on. So that is the testing portion of this project. And we can see that the physical implementation has correctly shown that no matter what, or no matter which of the 8 cases is presented by the user, that the physical implementation of the house lighting control system can correctly simulate that in real life. So I'm going to go ahead and turn all of these off now. And I would like to thank you all for joining today, and I will see you in my next submission. Thank you.